All right, so question 6. Answer the following questions given the equation that we have here of y equals x cubed plus 4x squared minus x minus 4. First question is to determine well, it's not even a question. First thing is to determine the remaining solutions given one solution is x equals 1. All right, we're going to use some synthetic division here. Now, the nice thing is it tells me that one of the solutions is definitely x equals 1. All right, so then if that's the case, let's go through. We'll start writing up our situation here. So I always like to use the hockey analogy. So in my penalty box over here, I've got 1. I'm going to grab all of the coefficients from here. So I've got 1, 4, negative 1, negative 4. Leave myself a nice space. All right, so now I got to go through and do synthetic division. Hopefully we remember this as we roll through. So the first thing is that whatever that first coefficient is, it's just going to come down. Take this value down here, this 1, multiply it by this 1, I get 1, so that goes here. Combine these two equations, combine these two numbers, so 5. 5 times 1 is 5. Combine these two, I get 4. 4 times 1 is going to give me 4. And then I get 0 here. Whoops, that's a 0, not a 6. So it told me it was one of the solutions. Thankfully, I got a 0 here, so yes, that is a solution. Now I'm left with the equation x squared plus 5x plus 4, and that equals 0 because we're still trying to find the solutions. Remember, another name for the solutions would be the roots, and yet another one would be the zeros. They're all the same. So now, I might be able to factor this, so let's try it. So let's see, we'll set up my parentheses equals 0. All right, first terms in each, x and x. This positive sign tells me the signs are the same. This one tells me they're both going to be positive, so we put plus and a plus. Now I need the factors of 4 that add to give me 5. 4 and 1. All right, so now that I've gotten that far, the next piece is, all right, well, what are the other solutions? Or what are the other zeros? Or what are the other roots? So now we have two other ones, and they are negative 4, negative 1. So determine the remaining solutions. Well, that's these right here. Okay, so we have x being negative 4, negative 1. All right, so now we've got a couple more questions that go with this. What's the end behavior of the polynomial? All right, so if we look up here, this is a cubic equation, okay? So cubic equation, great, but it's odd, which then usually odd, not usually, but when I deal with an odd degree, my ends are going to go in opposite directions. If this value is positive, which you can see that it is positive, when it's positive, then that means that we have the exact situation that I've got illustrated here. Now, for what we were working on in class, I said that it's fine for right now just to say that the end behavior, when we describe it, that literally this is good enough for the description. You're telling me what's happening at the end. Now, is that necessarily the best way? Not at the moment, but we will elaborate more on this after the MCA is done and we continue with the lessons that we're working on. All right, so sketch the graph of the function. All right, well, first off, of course, I need to add that this is my x and this is my y. We know the zeros, so let's take a look. We are going to cross. When we say zeros, it's where it crosses the x-axis, if possible. Okay, so I've got a 1, a negative 1, and a negative 4. So it's very similar to the one that we just did for number 5. So I'm going to come down here. Here's negative 1. That's one of the roots. 2, 3, 4. That's another one. And then we cross out here at 1. Now, I've already said, now first off, I want to just highlight over here, sorry, this says sketch. So for right now, because we're not asking you to do all kinds of plots with this at the moment, we know the ends look like this, and this is a rough sketch. All right, well, in order for me now to go through here, I don't just suddenly shoot over here. I've got to come down, curl around, backing up and through. Let's go up to the graph, or sorry, the equation here. Look at this number here. If x is 0, then that means y is negative 4. All right, let's come back here. If x is 0, that means y is negative 4. 1, 2, 3, 4. So now I actually have a turning point that I can go through. Now, I don't have a lot right here, but I can see that if I really wanted to find the exact points, I could substitute some in. So if I look at a -2 or a -3, I can figure out where I am up here. I'm actually going to do that just so that we can get a little more practice with using synthetic division. All right, so we knew it was a 1, a 4, -1, -4. Now I know this is not a 0, the function, so down here at the end I should not get a 0. That value is going to tell me where I'm going to go here. All right, so drop the 1 down. 1 times -2, -2. 4 and a -2 is 2. 2 times -2 is -4. Combine those, -5 times -2 is 10. So I'm up at 6. When I'm up at -2, I'm up here 1, 2, 3, 4, 5, 6. All right. Put a -3 in. Scroll down, give myself a little bit more room. So if I put a -3 in, okay, then I got 1, 4. Again, these are my coefficients of my equation. I'm going to drop the 1 down. 1 times -3, -3. Comes down to 1 again, -3. Bring those together, -4. -4 times -3 is a positive 12. So I'm at 8. All right, I only go up to 7, so I'm somewhere up here. Now I know that this has to start turning back because I really don't have any more room. Okay, and there's my rough sketch of the equation that we had up here at the top. All right, so that's the end of number 6. Let's take a look at number 7.